This video has to do with work. Now, what is work? Now, we think of work as more than the scientific definition. Whenever we go home and do homework or um, do chores around the house, it could be considered work in our society. But scientifically, work only happens when there's a change in motion of an object. And if you look up here at this guy pushing against the wall, he can push and push and push and push till he's as sweaty as can be, and he still will not have moved the wall. So scientifically, no work was done with him trying to push the wall, just because you have to have a change in motion of an object to actually have work done. Now you can see that we have a formula here for work. Let me get my red pen out. We have a formula here for work, and it's force times distance. Now we discovered that force earlier video was mass times acceleration, and that would be, I think, kilograms per times second squared. No, acceleration, yeah, meters per second squared. So that ended up being measured in newtons. So this force here is going to be in newtons, and the distance is going to be in meters. So it's going to be newtons times meters, and that's going to turn out to be what we call a joule. Now, it's not like a jewel on around your neck. It's a Joule, joule is how that's read. Now, sometimes if you're calculating things, you might want to have it as kilograms times meters squared times second squared if there are things you can cancel out, but we're not going to have any of those just yet that we will have to worry about. But anyway, work, I didn't mean to do that. Work is force times distance. I'll erase this. And we will actually calculate some actual work later on in this video. Now, something that has to do with work is power. Now, if you were to run up and down this set of stairs, and you were to walk up and down this set of stairs, you did the same amount of work. It's just that one of them didn't take as much time. If you ran up and down the stairs, it took more power, because power includes the time factor. Includes the time factor. So you have more power the smaller the amount of time. So we have power is work divided by time. So that's literally joules. Work is in joules, and time is going to be in seconds. So this is going to be measured in something called W, which is going to be a watt. So power is measured in watts. So we'll do some power calculations later on in the video as well. It is the rate at which work is done, which when it comes to cleaning rooms is pretty slow. Just thought I'd throw that in there. Well, machines help us do work. They help give us power to do work. And you can see here we have a ramp that's a simple machine. It's just an inclined plane. Sure, the work amount is the same. This big desk, I guess it is, needs to be lifted to the same area. It's the same amount of work done. It's just that these inclined planes and other machines means that we don't have to use as much power. These two people may not have had the power to lift a really heavy desk up there, so they needed some kind of machine to help them. And even if they did have the power, you wouldn't. It's easier if you have some kind of machine in which to help yourself. The ramp will allow the lifter to use less force in loading the heavy object. Let's go to another thing. Okay, final thing before we get to calculations is going to be mechanical advantage. Scientists and engineers use a number called the mechanical advantage to help make effective machines. Now, mechanical advantage, yes, we have another formula, and believe me, we'll work on this in a little bit, and we'll spend class time with formulas such as these. mechanical advantage formula looks like it's kind of a complicated one. Most of the ones I have seen tend to use this right here, the input distance over the output distance. Now that's the same thing as output force and input force. So if you happen to see it that way in your book or some other place, then know that that's the same thing. But here's more of a practical look at it. Here we have this lever here that has a fulcrum at it. So what's happening is you'd put something heavy right here, and you could push down on this side to lift it. Something you couldn't normally lift yourself would be over here. So the way scientists can figure out if this is something that will be in a mechanical advantage is they measure the distance. The input distance is the input of force that you are putting in. The input distance is on the side where you put the force. The output distance is going to be on that side with the heavy object. And you can see the input distance is 10 meters and the output distance is 5 meters. So if you have 10 over 5, then that's going to equal to 2. 10 is the input distance, 5 is the output distance, and that's going to equal to 2. And that's going to turn out to be a good number. The number you want to have on a mechanical advantage is at least 1. If the mechanical advantage is 1 or more, it does increase the force and it helps the person lift whatever object in this case. If it's less than 1, it just increases the distance and the speed. So if you had this particular fulcrum way over here, and we probably could have figured out that you would have had to have used more force here, to lift it up, and it wouldn't be as practical as if it were closer over here. Is a little more practical, and scientists could, or an engineer could have put in the numbers, measured the distance, and told you so with the mechanical advantage. Okay, let's see if we can do some exercises here. Okay, we talked about work. Work is going to be force times distance. So let's try this problem. How much work is done when 5 newtons of force moves a block 4 meters? So we've got work equals force times distance. So work equals, the force is 5 newtons. We'll go times. A block is 4 meters. Yes, newton meters is what we're looking for. So that was pretty simple. Work equals 20 newton meters or joules. Let's go to another one. Fred applies 350 newtons of force to move his stalled car 40 meters. How much work did Fred do? You know that work equals F times D, force times distance. So then you have work equals, what's the force? 350 newtons times 40 meters. So we're going to have the newton meters again. So I'll have to go down to the calculator there. 350 times 40. We have 3. Oh, 350 times 40 equals, looks like that will be 14,000. Looks like that will be 14,000 right over here. My wife's over here trying to do it all in her head. Did you get it right?
I beat you.
Oh, this is going to be the joy of teaching insane classes of her. So 14,000, let's see if that's correct as far as newton meters. Yes, 350 was in newtons and 40 was in meters. So yes, that would be 14,000 joules. I bet you didn't know that one, did you?
No.
Oh, there you go. That's going to be better. Okay, see, how far will 350 joules raise a 7 kilogram mass? This will be a little bit different. We have work equals force times diameter, but we already know the joules here. So we know the joules. We know the 7 kilograms. That's going to be kind of difficult there. So we know the 350 over here. Yeah, we're going to have to calculate. I don't think we have enough information there because we don't have the distance and the force. We need the mass times the acceleration. So we have the mass, but we don't have the acceleration yet. So we'll just skip over to that. We may have to go to that one in class. Oh, let's see. We'll go down to the next one. Okay, let's talk about power. How much power does it take to do 500 joules of work in 10 seconds? Remember, the power formula is work over time. Looks like this one will be a pretty simple one. Power equals work over time. So power equals, what do we have for work? 500 joules. And the time is 10 seconds. That'll be pretty easy. The zeros cancel out. So the power will equal 50 joules per second, which is what? It's watts, 50 watts. How much power does it take to lift 30 newtons 10 meters high in 5 seconds? That sounds like a whole lot of info right there. Power equals work over time. So what do we have of this? Okay, so we have Newton meters here. We're going to have to calculate what the work is. And remember, work is going to be newtons times meters. So we have to calculate the 30 times 10 first to get our joules. So it looks like we're going to have 300 joules is the work. And that's going to be over 5 seconds. So 5 into 300. What's that?
Oh, I'm doing something else.
Oh, she's doing something else. I thought she could answer that.
5 into 300?
5 into 300?
60.
60. So we got 60 what? It'll be 60 watts. Okay, let's see if we can get to mechanical advantage. We have about 2.5 minutes left on our video here. Okay, mechanical advantage is going to be input distance over output distance, or output force over input force. Let's see what we have here. It looks like distance. Output distance is 4.5 meters, so that's the output. It'll be on bottom. Input distance is 9.9 meters. So what's the mechanical advantage? Put mechanical advantage here. Let's see what we've got. Input distance is first, so that'll be 9.9 meters. Output distance will be on the bottom, 4.5 meters. So let's go down here to the dashboard. 9.9 divided by 4.5 equals 2.2. So do you get a mechanical advantage for that? Yes, you do, because 2.2 is higher than 1. And usually you get an advantage by using a machine that has a mechanical advantage over 1. Let's see what we have here. The power steering in an automobile has a mechanical advantage of 75. Oh, we're given the mechanical advantage. The input force on the steering wheel is 49 newtons. What's the output force that turns the car's front wheel? So we're given the mechanical advantage. See what we're not given. Mechanical advantage equals, we have output force here. So it's in newtons. So the output force is what we have. I'll abbreviate it OF over IF. Sounds like we're talking about conjunctions here. But anyway, we have the output force. So we're wanting input force to be what we're going to have. You know, this one might be best to plug the numbers in. So mechanical advantage is looking like 75. Wow, that's quite a mechanical advantage right there. Equals, output force looks like it is 49 over, let's go with X. So we had to get X on one side. That's going to be kind of complicated. So we multiply each side times X. Now I'm afraid I'm going to run out of time here. But we're going to end up on this side with 49X. Oh, I'm sorry, the X's cancel out. And we're just going to have